So BioCompute Object is a way to record what was done and why it was done in a bioinformatics experiment. Let me explain this using an example. So BioCompute, when Vahan, Simonyan, and I, almost 20 years ago, we were thinking about it. We are thinking about food recipes, such as pizza. So you want to make pizza at home. So you go and buy pizza dough. Well, it turns out to be awesome, and your friends say this was great, and you bought your vegetables and so on. Your friends try to repeat the same thing, and they get a pizza which does not taste the same. If you have made pizza, we know that in different grocery shops, the pizza dough is a little bit different. So having that information, if your friend had all the details, where the dough was bought from, a pointer, right? It was bought from this store, right? And this was the brand, what type of cheese. There's also the lot number and all of that. You can get into that level of detail. And if the recipe has all of these information, you can exactly reproduce the same dish really well, right? We understand this about recipes, but we understand it, but we never really followed it through for bioinformatics.
BioCompute is a complete recipe of not only the pipeline flow, but also all of the parameters, all of the inputs, all of the output. That's a completely consistent, reproducible piece of standardized information on a recipe. How do you produce this type of a computational outcome? I would not want to approve a drug when I don't know how one critical step is done. BioCompute is one layer more complex. When you assign a meaning to every single color, in this case it's a JSON format, it's not a CSV, so you assign a meaning to the variables in the structure. For example, it is important as to why this pipeline has been designed. So we came up with a usability domain. And then, for example, the next question was what versions of what tools have been used for this pipeline? Because it does matter. Yes, you get a different tool, different version, the answers might be different. And that's how we came up with execution domain. And then the next one, how did you parameterize your computation? What are the thresholds? What are the seed sizes? So all other parameters driving your machine. So that's how we came with parametric domain.
So it's important that the usage of the BioCompute also is well defined, and there are the standard actually goes into that. BioCompute is leading the way interoperability between platforms. So if Galaxy can use BioCompute, Hive platform can use BioCompute, 7 Bridges Genomics can use BioCompute. Now suddenly a user can use part of the analysis in Hive platform, part of it in Galaxy, part of it in 7 Bridges, but can record everything as a BioCompute when they submit. And that's pretty normal, by the way. It's super important to have this one umbrella which can record everything that was done.
Think about this, yes? I mean, you would think, how is the doctor connected to BioCompute? Yes, our clinicians connected to BioCompute. But if you have a device which is doing something important, yes, let's say I am dropping a blood here, it does some analysis, it does some measurements, and then analyzes it, shows you a number. That algorithm which is operating on this device is important to be consistent, reproducible, and that can be described by BioCompute as well. BioCompute is more encapsulated. Inside, there is a part of the BioCompute which tells you what the workflow is. That perfectly works with CWL, WDL, and other workflow definition languages. Yes, but by itself, there is no such an encapsulating standard which is alternative to BioCompute today.
Let's create an analogy to Wi-Fi. The 802.11 standard, more commonly called Wi-Fi, is a way of standardizing communications between vastly different products on a wireless network. If a product manufacturer wants a product to be able to communicate on a wireless internet network, they can configure the device to use the Wi-Fi standard, and it will be able to communicate with most commercial routers, regardless of whether the product is a Mac, a PC, a cell phone, or a smart toaster. BioCompute fills a similar need. It is a way of collecting and communicating information between two entities. BioCompute is not an automation or a new programming language.
BioCompute always came out of these big complex computations from biology and genetics, etc. But it's a much wider concept, yes? In the world where we live, the algorithmics and computations are part of our life. It's not just some scientific inquiry somewhere or other there. It's actually part of our lives. Devices are working in humans, with software embedded in them. Decisions driven by software outcomes are everywhere, and not just in medicine, every aspect of your life. For God's sake, your refrigerator is actually deciding how to cool and warm based on some kind of an algorithm inside of something. Yes. So if you think about wider dimensions of this, BioCompute is the first computational protocol standard in all industries. Yes. So that's why I think it has a life beyond biotechnology and things.